polymorphism is the ability of an object to take many forms. So poly means many and morph meaning forms. So I've got an example here where we have a parent vehicle class which stores the brand, model, year and has a couple of methods for starting and stopping a vehicle. And these are virtual methods, which in C# means that these methods can be overwrit by any subclasses or child classes. And we have a car child class which extends vehicle, meaning that it inherits these properties and methods from vehicle. And then what we're doing is we are overriding these start and stop methods in car, because, for example, starting a car involves some different logic than, say, starting a motorcycle or starting a plane. So a motorcycle is also a vehicle, and it overrides these start and stop methods, but there are different steps in starting a motorcycle, so we have to implement these methods inside of the motorcycle class. So you might be wondering, why do we bother extending vehicle with these start and stop methods when we're having to implement them or specify them within each individual type of vehicle? It doesn't really make sense. And the reason for this is because it allows us to use polymorphism, which essentially allows us to treat these objects in the same way. So let me demonstrate what I mean by what this means. So if we create a list of any object, so this can be any object in this list of vehicles, and then we just add some vehicles to this list. So we add a new car object, and we give it a brand of Toyota, a model of Camry, year 2020, and then we add a new motorcycle. So let's just call this Harley Davidson, and let's give it a model of let's see, Sportster, and let's give it a year of 2021. Okay, so now we have a list with two of these vehicle classes, but in this list we can have any objects. So we can add, a banana or a person. Even though we've called it vehicles, we can actually add anything to this list because it's just a list of objects. So let's say we want to perform some sort of vehicle inspection. So what we need to do is we need to loop through this list of objects. So we can say var vehicle in vehicles, and let's say we want to start the vehicle. So we want to test starting the vehicle. So we can call vehicle.start, but the start method isn't here, which is unexpected because these are all vehicles so far. We were expecting to be able to call this start method, but our program has no idea. It's not guaranteed that a start method exists on one of these objects because they're just any objects. They're not vehicles. So what we would have to actually do is we'd have to actually check what the type of this object is before we can call any methods. So for example, we would have to do this. If vehicle is of type car, we then have to cast this object into a car object. Okay, so we can say var car equals car vehicle. So we're casting it from a generic object into a object of type car, and now it's a car object. Now we know that it's a car object, we can then call car.start. Okay, but then if we want to also test, we also need to account for testing motorcycles and planes. So we then have to do another else if statement to say check if the vehicle is a motorcycle, for example, and if it is, we can say we can cast the object into a object of type motorcycle, and once we know it's a motorcycle object, we can call the start method. And then we would also have to do the same for plane. And the issue of this is, first of all, it's hard to read. We have to have a lot of if and else if conditional statements. And also, if we add more vehicles to our program, such as a boat, for example, then we also have to keep on modifying our client classes. The classes that are using these vehicle objects have to be modified, which is not good. We don't want to have to keep on modifying our code every time we add a vehicle. We just want to be able to add a vehicle and not have to keep on modifying our vehicle inspection logic. Okay? So how do we fix this? So first of all, rather than having a list of objects, we know that all of the objects in this list are of type vehicle because they're all extending the vehicle class. So we can say that this is a list of vehicle objects. And now when we loop through this list of vehicles, we know, because they're of type vehicle, and we know that all vehicles have this start and stop method, start and stop methods, we can simply just call vehicle.start, and that's it. It's that simple. So we've actually used polymorphism here because we're actually treating different types of objects as the same. We're just treating them as vehicles. Okay, we're not worrying about whether it's a car or a motorcycle or a plane. Because they're all vehicle classes which have these methods, we can just call the method directly and treat them all the same. Okay, so in this example, let's just sum things up. We have a list of vehicles containing instances of both car and motorcycle, and then we iterate through each vehicle in the list and perform a general inspection. So we're just starting the vehicle. That's just our simple inspection. And despite the vehicles being of different types, polymorphism allows us to treat them all as instances of the base vehicle class. The specific implementations of the start and stop methods for each vehicle type are invoked dynamically at runtime based on the actual type of each vehicle. And because the list can only contain objects that extend the vehicle class, we know that every object will share some common fields and methods, meaning that we can safely call them within the client code without having to worry about whether each specific vehicle has these fields or methods. So this demonstrates how polymorphism enables code to be written in a more generic and flexible manner, allowing for easy extension and maintenance of new types of vehicles as they are added to the system. So if we add another type of vehicle, we don't have to say else if vehicle is type of boat and then cast it to a boat and then call the start method, whatever the start method may be called on that boat, because we have no reason to actually call it start. We could call it start boat, and then we could call start boat. It doesn't even have to be called start if we don't extend the vehicle class. The vehicle class ensures that all vehicles have this start method, and we can treat all vehicles the same within our client code.